When NASA confirmed the updated arrival date of 3Y Atlas, the astronomical community was jolted by the realization that one of the most mysterious and enigmatic visitors to our solar system is going to arrive much sooner than previously estimated. This isn't just another cometary pass or routine celestial alignment. 3I Atlas belongs to the rare category of interstellar objects, those alien wanderers that did not originate in our solar system, but instead journey through the vastness of interstellar space before making a fleeting appearance near our sun. The confirmation of its sooner-than-expected arrival means that researchers, scientists, and space agencies now find themselves working against the clock, compressing years of preparation into a shorter time frame. Before we start, smash the like and subscribe buttons for more updates. The excitement around 3I Atlas stems not only from its classification, but from the very nature of what such interstellar objects represent. Humanity has only recently begun to grapple with the reality of objects passing through our solar system that are not gravitationally bound to it. The first was the cigar-shaped Oumuamua, which sparked countless debates about its origins, composition, and even its potential as an artificial craft. The second, 2I/Borisov, looked much more like a traditional comet but carried signatures in its dust and gases that hinted at chemical processes distinct from those seen in solar system comets. Now comes 3I/Atlas, and its earlier arrival forces researchers to rethink how quickly they can mobilize their observational networks and possibly even consider robotic mission concepts that might intercept it. One of the most compelling aspects of 3I Atlas arriving sooner is the timing. Normally, observing interstellar objects is an exercise in compromise, as their trajectories are steep, their velocities immense, and their windows of visibility narrow. Every day counts. A compressed timeline means astronomers must coordinate observations globally, ensuring telescopes across continents and in orbit remain trained on this rare traveler. The anticipation lies in what secrets its light and behavior may reveal. Will its gases betray the fingerprint of alien star systems? Will its dust grains tell us about environments far beyond our sun? The sooner arrival makes these questions all the more urgent, electrifying the scientific community with the sense that something monumental is at stake. For planetary scientists, the confirmation also highlights the importance of developing flexible strategies for interstellar object detection and study. With 3I Atlas arriving sooner than anticipated, the challenge is not merely scientific curiosity, but also logistical urgency. Time-sensitive projects are notoriously difficult to execute at the global scale, yet the rarity of such opportunities makes it imperative. If this object passes without sufficient scrutiny, humanity loses a once-in-a-lifetime chance to peer into the chemistry of other star systems, perhaps even catching hints about the building blocks of life as they exist elsewhere. The sheer rarity of interstellar objects also underscores why 3I Atlas is drawing such breathless attention. Our solar system has been around for billions of years, yet in the entirety of human astronomical history, only 2 such visitors had been confirmed before this one. Now, with 3I Atlas hurtling closer on an accelerated timeline, it is as though the universe has opened a sudden window into its deeper processes. The discovery challenges our sense of cosmic isolation, reminding us that we are embedded in a galaxy bustling with fragments of alien worlds. Each interstellar comet carries with it the memory of its parent system, chemical residues from a star that is not our sun, frozen snapshots of places that might be impossibly distant. To study one is to study the Milky Way itself in miniature. The public fascination with these objects should not be underestimated either. When news of 3I Atlas's sooner arrival spread, it did more than stir the scientific circles. Ordinary people felt the thrill of an alien emissary speeding into our neighborhood. Even if invisible to the naked eye, the knowledge that something forged in a different stellar nursery is sweeping past our sun evokes awe. It challenges the imagination, prompting age-old questions about where else in the galaxy life may have taken root. In this way, 3I Atlas does not just belong to astronomers. It belongs to everyone who has ever gazed upward and wondered what lies beyond. The technical implications of this early arrival are enormous. For spacecraft planners, every week counts when it comes to calculating intercept trajectories. If space agencies had considered a flyby mission to study 3I Atlas, the window is now narrower, the opportunity more challenging and yet potentially more rewarding. Although rapid mission deployment is daunting, the very possibility has already triggered discussions about whether humanity should develop ready-to-launch rapid response probes for precisely these occasions. The interstellar nature of 3I Atlas makes the argument even stronger. Unlike comets bound to our sun, these objects are fleeting. Once they pass, they vanish forever into the darkness. A failure to act is a permanent loss. Astronomers also recognize that a sooner arrival might mean a brighter display in our skies, at least through telescopes. Comets often flare when solar radiation energizes their volatile components, releasing gas and dust into space. With careful monitoring, scientists could learn how an alien object responds to our sun compared to native comets. Is it more fragile? Perhaps prone to breaking apart as it approaches? Or does it hold together with a composition forged under conditions unlike anything seen in our solar system? These physical reactions are key clues in unraveling the broader history of cometary evolution in different stellar environments. From a more philosophical angle, the early arrival of 3I Atlas forces us to confront the speed at which our universe moves. Humans measure time in days and years, but interstellar objects cross gulfs of space on scales that dwarf our perceptions. To think that 3I Atlas left its home system perhaps millions of years ago, wandered unnoticed in the void, and now suddenly streaks into our observational range is staggering. Its premature arrival is a humbling reminder that cosmic events obey no schedule that caters to our readiness. Instead, it is humanity's task to adapt, to sharpen its tools, and to be prepared when the cosmos decides to knock. As scientists ready themselves for intensive study, a wave of theoretical implications follows. Could the compositions of interstellar comets like 3I Atlas vary so dramatically from solar system comets that they redefine our models of planetary formation? If we find molecules in its coma that suggest complex chemistry, could that hint at universality in the way life's precursors are distributed across the galaxy? Each of these questions gains urgency because of the earlier timeline. The sense of immediacy pushes researchers to design novel experiments, refine spectroscopic techniques, and recalibrate observational schedules. The implications stretch beyond science into the realm of international collaboration. Observing an interstellar object is not the task of one observatory or one nation. It requires coordination across borders, time zones, and languages. The accelerated schedule means a test of how effectively humanity can come together for a shared cosmic purpose. If the world can rally to track a fragment of another star system, perhaps that same spirit of cooperation could spill into other areas of space exploration. In a way, 3I Atlas is not just a visitor but a catalyst inspiring new levels of coordination and vision. In classrooms and public forums, the story of 3I Atlas is sure to ignite wonder. Students will learn that in their lifetimes they are witnessing the passage of something ancient, something alien, and something unique. The arrival of such an object earlier than expected only heightens its drama, giving educators a rare chance to link cutting-edge discovery with age-old curiosity. For children, the knowledge that their planet is being visited by a wanderer from another star might inspire future generations of scientists, engineers, and dreamers who will carry forward humanity's journey to the stars. The arrival of 3I Atlas, confirmed by NASA to be happening sooner than projected, is a moment that compels humanity to widen its lens on both science and the cosmos. The revelation has pushed researchers into an accelerated state of preparation, but it has also opened new avenues for speculation, philosophy, and innovation that ripple far beyond astronomy. If the earlier than expected passage of this interstellar visitor has surprised the scientific community, the implications of its presence are even more startling. To understand just how much this event means, one must step beyond the telescope and look at the broader significance across fields of knowledge, human society, and even the collective imagination. The very fact that 3I Atlas is not native to our solar system introduces the notion of cosmic migration on a grand scale. Here is an object that was likely expelled from its parent star system billions of years ago, traveling through interstellar space in silence until it happened upon the sun's gravitational reach. Its earlier approach means astronomers will observe a pristine traveler, one relatively unaltered by repeated passes near our star, unlike comets native to the solar system. Its chemistry and structure might preserve conditions from a stellar nursery light years away, making it a natural time capsule of galactic history. A sooner arrival is, therefore, not just a scheduling adjustment, but an invitation to sample an untouched relic from another corner of the Milky Way. This timing also highlights the limitations of human preparedness when confronted with cosmic phenomena. Despite the advanced detection networks now scanning the skies, interstellar objects often announce themselves only months before arrival. With 3I/Atlas, the confirmation of a shorter timeline emphasizes the necessity of creating standing infrastructures for immediate study. Imagine if a probe had already been pre-designed, stored, and ready for rapid launch the moment such discoveries are confirmed. The lesson here is not only scientific, but institutional. Humanity must cultivate adaptability if it hopes to engage with the unpredictable nature of the cosmos. Another dimension worth exploring is the potential diversity of interstellar objects. While only 2 have been confirmed before, scientists suspect the galaxy is teeming with them. Countless fragments ejected during the violent early histories of other planetary systems? 3I/Atlas represents a rare observable example of this vast unseen population. Each interstellar comet could be chemically unique, its ice and dust marked by the peculiarities of its parent star's environment. The fact that this one is arriving sooner adds weight to the possibility that interstellar objects are more common than we thought, and our detection technology is only just catching up. If this is the case, the arrival of 3I/Atlas could herald a future in which such discoveries become routine, each new one adding to a galactic library of planetary ingredients. The implications extend into astrobiology as well. One of the great scientific questions of our time is whether life is a universal phenomenon or a rare fluke. Interstellar comets like 3I/Atlas may provide critical evidence. If its composition includes amino acids, organic molecules, or other precursors to life, it would suggest that these building blocks are not confined to one star system, but are widespread, strewn across the galaxy by ancient collisions and gravitational expulsions. This would give credence to the theory of panspermia, the idea that life might spread through interstellar space aboard natural carriers like comets. The earlier arrival only intensifies the urgency of examining this possibility before the object slips back into the darkness. Beyond the realm of science, there is an undeniable cultural and psychological impact. Interstellar visitors hold a mythic quality, echoing the stories of wandering messengers found in the legends of many civilizations. The announcement that 3I/Atlas will pass sooner adds a sense of drama, a narrative of urgency that captures imaginations. For artists, writers, and filmmakers, the event is fertile ground for exploration, an alien fragment speeding into our lives and vanishing just as quickly. It feeds into humanity's age-old fascination with signs from the heavens, though this time grounded in the precision of astrophysics rather than mythology. Technology, too, stands to benefit from the compressed schedule. Instruments and techniques developed to study 3I/Atlas could have lasting impacts in other domains. High-speed spectroscopic methods, rapid coordination of telescope arrays, and enhanced data processing pipelines may all evolve under the pressure of this event. The accelerated innovation curve resembles wartime mobilization, except the adversary here is time itself. Once developed, these tools will remain in use, strengthening humanity's ability to respond to future cosmic surprises, whether interstellar comets, near-Earth asteroids, or other unexpected phenomena. The early arrival also emphasizes the global nature of space science. No single observatory or nation can track an interstellar object effectively on its own. Instead, an international network must coordinate observations, pooling resources to ensure continuous coverage. This necessity promotes cooperation at a time when geopolitical tensions often dominate headlines. A traveler like 3I/Atlas does not respect human borders. Its path across the skies is shared by all, and in tracking it, humanity is reminded of the benefits of collaboration. The compressed timeline forces this cooperation to be swift and efficient, providing a rare opportunity to prove that the global scientific community can function as a unified whole. Philosophically, the object's early arrival prompts reflection on humanity's relationship with time and expectation. Science thrives on prediction, on carefully mapping the future based on current understanding. Yet here is a reminder that the cosmos remains unpredictable. The unexpected acceleration of 3I/Atlas challenges the assumption that humanity can always prepare at leisure. It calls for humility in the face of the universe's vastness and unpredictability, This humbling realization may influence how humanity approaches not just astronomy, but existential challenges such as climate change, planetary defense, and resource management. The universe is dynamic, and adaptability becomes as important as foresight. Consider, too, the role of the public in shaping the trajectory of such discoveries. With the earlier arrival confirmed, media coverage is bound to expand rapidly. Public enthusiasm translates into political will, which in turn can lead to increased funding for space science. The last time interstellar visitors were confirmed, the excitement was palpable, but it was also fleeting. The urgency of 3Y Atlas arriving sooner may sustain interest long enough to transform policy, inspiring long-term investments in detection networks and rapid response missions. It is a reminder that scientific opportunity and societal momentum are often intertwined. The physical dynamics of the object itself become even more intriguing under the circumstances of its sooner arrival. Its trajectory, velocity, and orbital mechanics are keys to understanding how it was ejected from its home system. Faster than most solar system objects, it carries with it clues about gravitational interactions with distant planets or stars. An earlier than expected approach sharpens the challenge of measuring these parameters, but also heightens the excitement. With every refinement of its orbit, astronomers may be able to trace back its origin, perhaps even identifying the specific region of the galaxy from which it came. If so, 3I Atlas would not just be a nameless visitor, but a representative of a distant stellar family, a tangible connection to the broader galaxy. From a more speculative standpoint, the interstellar nature of 3I Atlas invites questions about technology and exploration far beyond current capabilities. If humanity eventually develops interstellar probes, they may encounter objects just like this one in the vast void. By studying 3I Atlas closely, scientists essentially rehearse for a future in which humanity is no longer confined to the solar system. Its composition, behavior, and dynamics could inform how future explorers detect, analyze, and even interact with interstellar bodies. The earlier arrival thus acts as a catalyst, prompting the imagination to leap centuries ahead, envisioning humanity's place among the stars. Another layer of significance lies in planetary defense. While 3I Atlas poses no threat, its earlier approach highlights how quickly celestial bodies can surprise us. If this had been a massive object on a collision course with Earth, the compressed timeline would have been catastrophic in terms of preparation. Studying 3I/Atlas, therefore, doubles as a case study in how humanity might respond to unanticipated space hazards. It underscores the need for more vigilant scanning of the skies and the development of strategies not just for studying interstellar visitors, but for deflecting potential threats. The sensory experience of its passage should not be overlooked either. Though likely faint to the naked eye, the comet's tail may become visible through moderate telescopes, offering amateur astronomers around the world a direct link to the event. The earlier arrival means stargazers will have to ready themselves quickly, setting up equipment, planning observations, and sharing their data online. This democratization of discovery, in which professionals and amateurs alike contribute to the global picture, exemplifies the participatory nature of modern astronomy. The thrill of capturing an image of an alien comet fuels enthusiasm and bridges the gap between the scientific community and the public. If one considers the history of astronomy, moments like this are rare milestones. The early arrival of 3Y Atlas adds a twist to that history, ensuring its place as a turning point in how humanity perceives interstellar space. The discoveries made could echo through the decades, influencing research directions, inspiring space missions, and embedding themselves in cultural memory. Just as Halley's Comet left a mark on civilizations across centuries, so too may 3I Atlas leave a legacy. Not because of its brightness or beauty, but because of its alien origins and the urgency of its fleeting visit. The convergence of science, culture, and imagination surrounding this object illustrates the holistic nature of space exploration. Every detail of its composition matters scientifically, but the narrative of its journey matters culturally. It is both a data set and a story, both a chemical fingerprint and a myth in the making. The earlier arrival magnifies this duality, infusing the story with urgency and immediacy. Humanity is not watching a slow, predictable spectacle, but a sudden encounter, a flash of cosmic drama that must be seized before it fades. In the broader arc of human progress, The confirmation of three I-Atlas's sooner arrival may eventually be seen as part of a continuum, the early phase of a new era, in which interstellar objects are routinely detected, cataloged, and studied. This particular event may galvanize investment in technologies that make future encounters less rushed and more deliberate. It might inspire a generation of astronomers to specialize in interstellar object studies, building a new subfield within planetary science. The momentum could even contribute to the eventual decision to pursue interstellar travel, as the urge to follow such objects back to their origins becomes irresistible. The symbolic power of an alien comet racing into view cannot be overstated. It embodies the unknown, the unreachable, and the fleeting, all themes that resonate deeply with human consciousness. Its sooner arrival only heightens the sense of a fleeting opportunity, a rare chance to grasp at the larger mysteries of existence. In this sense, 3I Atlas is more than ice and dust. It is a mirror held up to humanity, reflecting both our hunger for knowledge and our limitations in time. As telescopes prepare to record its every move, as scientists ready instruments to analyze its spectrum, and as the public looks up with renewed wonder, the stage is set for a unique chapter in humanity's relationship with the cosmos. The early arrival does not diminish the significance of 3I Atlas. It enhances it, sharpening the sense of urgency, magnifying the stakes, and reminding us all that the universe does not wait. It delivers its mysteries on its own timeline, leaving us the choice of whether to meet them with readiness or regret. The journey of 3I Atlas across our skies will be brief, but its influence will last far longer. The data it yields, the technologies it inspires, the collaborations it fosters, and the imaginations it ignites will ripple through science and culture for years to come. It is a messenger not only from another star, but from the universe itself, reminding us to look up, to prepare, and to embrace the fleeting beauty of discovery. Its earlier arrival is not a setback but a gift, a chance to prove that humanity can rise to meet the cosmos even when the timeline is shorter than expected. The announcement of 3I Atlas's sooner than expected arrival reverberates far beyond its astronomical context. What sets this moment apart is not simply the presence of an interstellar visitor, but the way it challenges humanity to rethink the rhythm of discovery, the readiness of institutions, and even the very nature of how cosmic events are woven into our understanding of existence. With time compressed, the event sharpens focus and demands bold thinking, and it opens doors to entirely fresh lines of exploration. One of the most immediate areas affected is the discipline of celestial mechanics. Astronomers thrive on precision, calculating orbital paths with extraordinary accuracy. Yet 3I Atlas's accelerated timeline underscores that even the most advanced models can be thrown into flux by subtle gravitational influences or observational limitations. The need to refine predictive models becomes more urgent, not only for scientific completeness, but for the sake of readiness when similar objects appear. This has implications for the calibration of instruments, the construction of algorithms, and even the training of the next generation of researchers who will inherit these challenges. The early arrival also shifts attention to the sun's role as a cosmic laboratory. Each time a comet, whether local or interstellar, approaches the sun, it undergoes a transformation. Ice sublimates, gases vent, dust scatters, and tails form. For 3I Atlas, the specific chemistry of its outgassing may reveal what kind of stellar radiation and cosmic environment shaped it long before it wandered into our neighborhood. Observing these changes in real time becomes doubly exciting when the clock is ticking faster than anticipated. Solar probes like Parker and upcoming missions could provide unprecedented perspectives, catching how an alien body interacts with solar winds and magnetic fields, yielding data that speaks to processes not confined to one star system. There is also a profound geological implication to consider. Earth's earliest history was shaped in part by cometary impacts, which may have delivered water and organic material to the young planet. The appearance of 3I Atlas allows us to test whether interstellar comets could play similar roles elsewhere. If alien comets can deliver such ingredients across systems, then planetary development throughout the galaxy may share common threads. This realization reframes geology itself, not as an isolated planetary science, but as a field tied to interstellar chemical exchange. The shorter timeline only deepens the pressure to gather data that could redefine our understanding of how planets evolve across the galaxy. Equally intriguing is how the earlier arrival highlights the limits of human perception and detection. Astronomical surveys have grown immensely powerful in recent years, yet the fact that such objects still surprise us indicates a gap in coverage. This gap raises questions about what else passes unnoticed. How many interstellar wanderers have slipped past without detection? How many stories, written in ice and dust, have we missed because they never came into focus? The urgency of 3I Atlas magnifies this concern, driving home the point that detection technology must evolve not just incrementally, but radically. This might mean larger sky surveys, more autonomous detection algorithms, or even space-based observatories dedicated solely to catching these cosmic interlopers before they vanish. Another fresh layer of significance emerges when considering the sociology of science. The compressed preparation period will force collaborative teams to operate at a heightened tempo, collapsing bureaucratic processes that often slow progress. In doing so, 3I Atlas may serve as a model for how science can accelerate when driven by urgency without compromising rigor. Lessons learned in organizing international observation campaigns could spill over into other fields, showing how speed and quality need not be mutually exclusive. In a world where many challenges require rapid yet careful responses, this demonstration of scientific adaptability may be as valuable as the data from the comet itself. The interplay between technology and philosophy is also sharpened by this event. Humanity has long debated its place in the cosmos, asking whether we are isolated or part of a larger continuum of worlds. The early arrival of 3I Atlas brings that debate into sharper focus. Here, undeniably, is a piece of another world passing through our domain. It is tangible evidence that we are part of a galactic ecosystem, not an isolated oasis. This realization may shift philosophical discussions about human uniqueness, destiny, and our obligations to explore beyond. The element of time, shorter, swifter, more fleeting, serves as a metaphor for the urgency of grappling with these existential questions before the moment passes. Education stands to gain as well. The arrival of such an object sooner than expected can transform curricula in real time. Teachers and professors now have an unfolding case study to present, one that brings together physics, chemistry, astronomy, and philosophy in a way few events can. Students can track developments day by day, connecting theoretical concepts with actual discoveries. The immediacy of the timeline makes the lesson vivid. Science is not static, but dynamic, demanding constant adjustment to new realities. For young learners, this may be the spark that ignites a lifelong passion for exploration. The arrival also prompts deeper consideration of how humanity interacts with fleeting opportunities. In daily life, we often think in terms of long-term goals and gradual progress. Yet the cosmos delivers moments that demand immediacy. 3I Atlas embodies the challenge of the ephemeral, teaching us that not all discoveries can be approached leisurely. Some must be seized in the instant or lost forever. This has broader applications, suggesting that humanity must cultivate an ethos of readiness, not just in science, but in every realm where the unexpected can reshape reality. On the cultural front, the early arrival could inspire entirely new creative movements. Artists may interpret the interstellar visitor as a symbol of urgency, of fleeting beauty, of the alien within the familiar. Writers may weave stories in which a comet from another star becomes a catalyst for change, or a metaphor for opportunities lost and found. Musicians may compose works that capture the suddenness of its passage, the drama of its alien nature. In this sense, 3I Atlas is not only a scientific event, but a cultural one, expanding the palette of human creativity with its unexpected timing. Policymakers, too, will feel its influence. With 3I Atlas highlighting the unpredictability of interstellar objects, arguments for increased funding in planetary science and rapid response capabilities will gain traction. Legislators, often driven by immediate concerns, may find in this event a tangible example of why foresight matters. If the early arrival can be leveraged to secure long-term investment, it could shape the direction of space science for decades to come. The ripple effect might extend beyond astronomy, reinforcing the importance of preparedness in fields from climate policy to disaster response. At the heart of the event is the theme of perspective. The sooner-than-expected passage of 3I Atlas is not only about what we will learn from the comet itself, but about how it reframes our understanding of scale and speed in the universe. To us, the shift feels dramatic, months or years shaved off the expected timeline. To the cosmos, it is trivial, the result of orbital mechanics unfolding as they always have. This contrast between human urgency and cosmic indifference is humbling, reminding us that our timelines are fragile and subjective against the backdrop of galactic motion. The event also reopens the debate about what constitutes the borders of the solar system. Traditionally, we define our system by gravitational influence, with the Oort cloud marking the distant edge. But when interstellar objects like 3I Atlas enter, they blur those borders, reminding us that the solar system is not a closed system, but a porous one, constantly exchanging matter with the galaxy. The early arrival emphasizes this porosity, as if to say that the solar system is less an isolated family and more a crossroads at which countless travelers pass. This idea has profound implications for how we conceive of our place in the galaxy. Looking to the future, the arrival of 3I Atlas may inspire entirely new kinds of missions. Rather than waiting for discoveries and scrambling to react, space agencies may design fleets of interceptors stationed in orbit, ready to launch at a moment's notice. Such missions would represent a new class of exploration, proactive rather than reactive, designed for the unpredictability of the cosmos. The earlier than expected timeline provides a case study in why such preparations matter. Without them, humanity risks missing the most profound opportunities simply because they arrived ahead of schedule. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on NASA confirming 3I Atlas's earlier arrival date? We want to hear from you. Thank you for watching and see you next time.